I'm happy to see so many people here. My name is Matthias Wienand, and this is Tamas Miklossy.
Hello.
We are both committers on the GEF project, and we want to show you the Graphviz authoring environment that is implemented or provided by GEF for Eclipse. It's called GEF DOT. It's also a component of GEF. And I will start by introducing the team around GEF to you. And afterwards, we will have a demo of the Graphviz authoring environment. And then I say some more information about GEF in the end. OK, so let's start. Okay, this is an older picture of me. And this is Tamas. He's interested in graphical and textual modeling, and that's why he ended up doing GEF DOT a lot, because he can develop the DOT language with Xtext, and he can develop the graphical view with GEF. Yeah, so it fits perfectly. This is Alexander Niesen. You probably know him already. He's the former project lead. I took over the role now, and I messed up one release already. But now I know what to do, and the next one will be fine, I guess. Yeah, he's still helping out. He's still a committer on the project, and we can ask him about software architecture, about technical details, and also release engineering is there for us. These are Fabian Steg and Zoltan Oyehei. They are both also committers on the project, and they were helping with layout and Zest a lot. Fabian was co-lead or project lead, I'm not really sure, of the Zest project back in the day. And when we were bringing it over to Java FX, he was doing most of the migration there. And Zoltan is an expert in layout algorithms, and he was researching that also. And so, yeah, we can get back to him if we have questions there, which is nice. But I never met them in person yet. Yeah, maybe someday. This is Hannes Niederhausen. He's not a committer, but a contributor on the project. He's the one who implemented the mind map tutorial. So some of you may know him or know the tutorial. And he's an interesting guy. He's a fiction author. He authored a book already. And also he knows a lot of beers. Yeah, and of course we have Zoe Garrett Prigge. He's a student at University of Düsseldorf. And he's interested in linguistics and computer linguistics. And that's why he's working on DOT as well. He's working closely with Tamas, and these two guys are who implemented most of the features in the past year. Because in GEF DOT there was much progress, or most progress in the framework at least. Okay, so what are we going to talk about? It's the top-level component of GEF DOT. As you can see here, this is a diagram that's depicting the dependencies of the individual GEF modules or GEF components. The components are all in the same color. Probably saw this picture already somewhere. And as you can see on the top, there is .UI, which is the DOT component. And it got dependencies on most other GEF components. So we can show you some of the features or many of the features by presenting DOT to you. Okay, so I hand this over to Tamas, who will tell you something about Graphviz and then do the demo.
Thank you, Matthias. So, first of all, I would like to introduce Graphviz, explain it a little bit. So, Graphviz is actually a set of open source tools for drawing graphs, and DOT is actually one component of this tool set. This is the language itself to describe the graphs. So this is actually a domain-specific language to define graphs. And this language is defined by a host grammar and also provides a lot of attributes, more than 150 attributes to influence the visualization, which we can define on the graph, on the nodes, and on the edges. And these attributes are also defined or described by subgrammars. And at the end, on the top, at the bottom, you can see two graphs which are defined in this language. And the Eclipse DOT authoring environment consists of actually three main parts: an Xtext-based textual editor, a Java FX-based graphical view, and we are using the Graphviz executable for image exporting and for also layouting. So now I switch to the demo. So what you can see, this is the Eclipse environment, and the latest version of the GEF component is already installed. So first of all, if we would like to start defining the graph, then we have to create a file with a special extension. So I have to use the extension dot for the text file, and after that this editor opens, and we can start defining the graph. First, we start a keyword with a keyword graph, and after that, in curly braces, we already defined an empty graph. We also have the possibility to define nodes, and if we would like to trigger the visualization, then we can use the context menu show in dot graph, and then you see that the graph with one node shown up on the right side. We also have the possibility to extend this definition. If we define additional node, we can save and trigger the visualization once more. Then you see that an additional node also shown up. Here you can see also the outline view, the content of the file. We can see that the file contains one graph with two nodes, and here you can see this small question mark indicating that this graph doesn't have a name, so we can give it a name, and after that you see that the outline view also updates, and the name of the graph is also present. So we also have the possibility to define edges, and for edge definition we can use this template. If we trigger this template, then you see that we have two placeholders, one for the source of the edge and one for the target of the edge. Then we can define that we would like to have an edge between the node 1 and 2. And if we save this, then you can see that the edge is also drawn. So I can format this a little bit and also convert this to a directed graph. For directed graph, we have to use another keyword, and changing this keyword, we also see an error message that actually another symbol is expected to connect the nodes. So we can trigger this quick fix, and you see that the symbol has been changed. And if I save this, then you can see that an arrow decoration is drawn on the edge of the edge. These are actually all default visualization styling. We have the possibility to use attributes to influence this visualization. For example, if we would like to have an empty arrowhead, then we can use the arrowhead attribute. With this value, O normal value, and then you can see that the arrow is not filled in anymore. We also have the possibility to extend this further. So if I copy this once again, then you see then two arrow decoration are drawn, and I can also influence the visualization using two letters, left and right. And if I save this, then you can see that only the decoration are drawn only on the left or on the right side of the edge. We can also define attributes on the nodes. So the default shape is an ellipse, but if we would like to use another shape, for example a circle shape, then we can enter this attribute value and the visualization changes to a circle. And we can also use labels. So the label of the nodes are default, are the ID of the nodes by default. And if we would like to change this, then we can use the label attribute to define a more meaningful label on the node. Here we also have the possibility to define special symbols in the label. For example, curly braces and pipe symbols, and even new line symbols. And if we save this, then you can see that the view is updated using this, visualizing these symbols. And if we define that the node 2 should have a special shape, a so-called record shape, then this means that the label has to be evaluated in a special manner, defining two compartments. So the first compartment is the left side of the pipe symbol, and the second compartment the right side of the pipe symbol. We have also the possibility to use colors. Here we already have some predefined green colors. So if I use this dark green color, then you can see that the outline of the shape, the color of the outline of the shape has been changed. We can also use colors for the edges. Maybe here we can use an orange symbol. Here you also see on the left side additional information of the color. So by the name, it's actually quite difficult to decide which color is behind this value, so that we see the color code that we can use, so that we can know which color is actually behind this value. And if we save this, then we see that the color of the edge also updated. The further language definition and language features I would like to show on more advanced examples. So I prepared some additional example. For example, this dot graph view is a definition of a UML state machine. Here you can see that it is a directed graph. The graph has a name finite state machine, and it has some parameters to influence the layouting and the size of the graph, and also declares a global node attribute for 4 nodes, and also a global node attribute for all the upcoming nodes, and also the labels with the corresponding label, or edges with the corresponding label attributes. If we take a look at the visualization of this graph, then we see this state machine. Maybe I can switch to this. And here on the right side, you can see that the start and the end nodes are visualized by double circle shapes, and all the inner nodes are visualized by a circle shape. So actually, if we would like to change this a little bit to be able to visualize a proper UML syntax, then we would like to visualize the start node with a filled circle and the end nodes with a filled double circle. So in order to do this, I take this node and define that the shape, circle shape, should be used for the first node. And if I save this, then you can see that the shape of the first node has been changed. And I would like to also use the field style. So if I enter the field style, then we can see that all the nodes are filled, but actually we would like to have that only the start or the end nodes are filled. The inner nodes we don't want to have filled, so that we have to reset the style attribute after that, so that we can see that all the upcoming nodes are not filled anymore. We also have attributes to influence the visualization. So the reindeer attributes is currently defined to LR, meaning left to right. So it means that the graph is drawn in a landscape mode. And we can also use other attributes, for example, TB, top to bottom, and it means that the layouting has been changed. So now most of the edges are pointing from up, from the top to the bottom. So other further examples I would like to show is an expression syntax tree visualized by the Antler dot tree generator. Actually, on the left side you see an expression, and on the right side you can see the abstract syntax tree of this expression. So actually it contains two expressions, and on the tree you also see the left subtree and the right subtree containing the elements. And here we are using the light green background color attribute to have a background color gray background color on the graph. And we are also using arrow size attribute on the edges to define the size of the arrow heads. And if we would like to have bigger arrows, then we can increase this value a little bit. And if we store this, then we will see that on the visualization we have bigger arrows. The third example is actually a kind of dependency visualization. I increase this a little bit. And here you are seeing the different GEF components in a layered architecture. So at the bottom you can see the GEF common component. This is actually the basis of all other components. And in the middle you see the MVC component, and on the top this is actually what this talk is about, is the GEF DOT component. And in order to be able to visualize this graph in a grid, we are using subgraphs. So we are grouping the first column, the elements of the first column and the elements of the second column in subgraph, in invisible subgraph, so that we can define additional attributes. Then we can say that we would like to have that all the elements of the subgraph should be layouted in one row or in one column. So the next example is a visualization of a Git branch merging workflow. This is a little bit big, the graph definition itself, but on the visualization you can also see the different branches, and we are using each subgraph. For each branch we are using one subgraph with different colors, and here we are using for the tags special shapes, and we are also defined so-called tooltips on the shapes, so that we are able to provide additional attributes, for example the name or the date of the tag. And this also works for other nodes, for inner nodes. This is actually, if you see a commit, it's always good to see the message and the date of the commit. So the next example is actually AMF visualization of graph definition. Consider this graph definition. We see that we have a directed graph with one attribute. The background color is set to light blue, and here we see one edge. On the left side we see one node, and on the right side we see a subgraph with two nodes, 2 and 3. And if we read this textual representation and load it into the memory, then we create the AMF instance model, and we also have the possibility to generate a graph definition from this instance model. Maybe first I show you the visualization. And here you see that this is the textual representation of the graph, and this is the abstract syntax tree representation. So actually it contains one graph, with a type digraph, and it further contains one statement, one edge statement, and one attribute with the name BG color and with the value light blue. And further you see that we have one subgraph with a directed edge, and the node ID on the left side of the edge we see the node ID 1, and on the right side we see a subgraph with the name cluster, and so on. You see the visualization. If we take a look at the graph definition itself, then here you see that first we define the graph, and after that we define the nodes, and we define the edges between the nodes, and each node is defined using the so-called HTML-like label, so that we describe the shape of the node by an HTML table which is coded into the node label. Here you see that we are using HTML tables with different rows and table data, and we have also the possibility to design attributes on that, for example the cell border and align attributes, even color of the table can be determined. So the further examples, I already prepared some additional examples, but that I don't want to show now. So these are available on the GitHub repository, and you can download it, take a look at it. The next part, I would like to show you how we can use this component, actually this textual definition of a graph, so that we can provide visualization for other languages, for Xtext-based domain-specific languages. So I close this. So the first example is actually DSL to be able to describe expressions. So the first expression is actually the simplest expression, is only one operand having a value 1. And here I have also the possibility to see the visualization of this expression. And here you see that one node shown up. If I extend this expression to be more complex, I have to switch this on. Then you see that on the right side we see the operands 1, 2, and 3, and also the plus operator, and we are also visualizing the value of each sub-expression. For example, this sub-expression evaluates to 3, and this also evaluates to 3, and the end of the sub-expression, maybe in a small tooltip you can see that this is 6. And if we consider another expression using parentheses, then here you see on the left side that the result is 6 in both cases. But if we create the visualization, and if we set this next to each other and compare them, then we see that the sub-expression are different. Here I have also further more complex expressions definition. Maybe I show you one more. Here we defined one function and also one call for this function. And the visualization on the left side, this function is defined using the subgraph, and this is actually the call on the function. So the next example, is actually a DSL to define domain model elements. Here you see 4 elements, 4 entities. These entities can have attributes and can also have relations to each other. For example, the first entity is a blog entity, the second entity the has author entity, and the fourth, or the third and the fourth entities are the special has author entities. So we can, it should be useful actually to have some kind of UML class diagram like visualization to this language. So if I trigger the visualization, then we see that on the top we see the has author entity, and we see the 2 special entity, special has author entity, post and comment, and we are also seeing the properties in different compartments attached to the node. The next example is a state machine example. Here the user have the possibility using this language to define state machines, so states and transitions between the states. And if we take a look at the visualization, then we see that the states are defined, are visualized using nodes. The transitions are visualized using edges, and the commands are attached to the nodes in an additional compartment, and the events are visualized in the label of the transition edges. The last example I would like to show you is actually DSL, so that we are able to define devices, and these devices can have different states. Here you can see 2 devices, window and a heater, and the window has 2 states, open and closed, and the heater has 3 states, on, off, or error. If we take a look at the visualization of this, then we see that each device is visualized by one subgraph with a corresponding label, window and heater, and the states of the device are visualized as nodes in the subgraph. In this language, we have further possibilities to define rules. So here we see 4 rules describing transitions between the device states. The first rule describes, for example, if the window is open, then the heater should go off, and if the heater is on, then the window should be closed. And the last rule defines if the window is closed, then the window should be closed. So this is actually firing the same event. The rule fires the same event that triggers the rule, and that's why this language recognizes this as a warning, and also saying the message that this could be a problem or a design mistake. So if we take a look at the visualization with the rules, then we see on the right side that the rules are defined using or visualized using the edges, and the last rule with the warning are styled so that we are using yellow font color, yellow color for the edge. So actually how this is working, how this is implemented. So we take this domain specific language and we are translating this into an intermediate dot graph. So if I open the generated file, then actually first the user is working on this textual representation, and after that this intermediate textual representation of a graph definition is generated, and the view is triggered by this graph generation, so that you see that in this generated graph, we have some global attributes, and we have one subgraph for each devices, and for the 4 rules, we have the 4 edges, and here we are using also the gold color for the warnings. So these examples are also available on GitHub. You can download it, try it out. Now I will hand back to Matthias, and he will conclude our talk because we only have 4 minutes left.
Okay. Thank you, Tamas. Okay, so you've just seen some features of GEF DOT, and I think some of them look quite good already, but there are some rendering inconsistencies, some rendering bugs or artifacts that we still need to resolve, and also we don't yet provide support for all the attributes that Graphviz provides. So we still need to do something. One of the things is the refactorings, XX refactoring, so this is not in the visualization but in the editor. There, for example, there was one example where there were many edges defined with the same attributes, and we would like to offer a refactoring for packing these into a statement that, that will provide these attributes for all upcoming edges. So to simplify the graph definition, we want to provide some more XX refactorings. The next thing is the HTML-like labels. You've seen at least one example of them in the demo, but I don't know if you could pick it out, but there were some gaps between edges and nodes when using HTML-like labels because we get some of the computations wrong. And this is something we're working on for a long time, HTML-like labels in general, and we still need to fix some inconsistencies there. And also, we want to be able to highlight which node is referencing, which graph node is referencing the visualization. So when you click into the visualization, we would like it to show where this comes from, what is this generated from, and also for the edges, and it should work in both ways. Yeah, and the last thing is bundling the graphics executable with Eclipse. We still want to do that. It's more troublesome than we thought, but we still got it on our list. And this is the upcoming word for dot. But we also changed something else. Recently, we were looking at the Bugzilla, and we got over 100 issues with GEF now. And we decided to mark some of these issues as low-hanging fruit so that new developers could possibly be able to start working on these issues because they don't require deep knowledge of the framework or much research beforehand. And this is just a small list of issues that we marked as low-hanging fruit. And there are many more, but there is at least one issue per component, so you can actually pick what you want to work on and what is your topic, and see if you can find an issue that you like to work on, and we hope to get some more contributions in this way. Yeah, but we still need to work on this a little bit more. But yeah, that's something we want to get people involved more. Okay, so thank you very much for your attention. And now it's time to ask questions, and don't forget to vote. Yeah, and this is how to get involved.
The dot editor view,
yeah.
We saw something like this highlighting effect when you hover over it.
Yeah.
Is there some other functionality like selection and
actually
there's this issue with selection synchronization? I guess that's about that, or
no, you can actually select stuff and you get a feedback highlighting. But actually, this is based on Zest, and Zest provides much more interaction capabilities than the dot graph view because we were stripping it down. We said, okay, dot graph view is just a view. You don't want to interact in there, and so we took everything away that you don't need. So you can navigate, you can highlight things by clicking on them or hovering them, but everything else that was possible in Zest, like manipulating the connections, we took that away from it. But since this is not yet API, yeah, you can still extend on the dot graph view and add your own interactions if you want to.
But you can use selection. Is this synchronized with the outline view or with the textual view?
Is it synchronized with the outline view? Okay, it's not even synchronized with the outline view, but it's propagated over the Eclipse selection service. So you can grab it and do something with it. We just don't do it yet.
Actually, this is something we would like to improve in the near future.
Yeah.
Regarding layouting, do you still use only the Graphviz properties, or is it possible to use ELK layouting mechanism?
It's not yet integrated. I've seen it integrated, not with dot graph view, but with other GEF views. So it's definitely possible, but we don't yet provide it in this.
And regarding the bundling of Graphviz right now,
Yeah.
so you said that okay, there is a CQ on IPZilla, but
Yeah.
unfortunately it's withdrawn. So
Yeah.
because of no further action.
That's right, but we still have the ticket in our Bugzilla, and we want to get it to Eclipse, but we need to get a guy to compile it on Windows for us.
And then the current solution is someone should configure it in the property or preferences page.
Yeah.
Make use of these features.
Yeah, that's right. So you can provide the location of your Graphviz executable, and it will work. Right. But it would be much nicer if you could just hand out a plugin where Graphviz is contained. We do this actually for customers. So we use the published version of Graphviz. We provide it for Linux, Windows, and Mac OS. Have it in a plugin, and then you consume it. But we can't push that to Eclipse yet because of the IP issues. So
It's GPL or what's the IP issue?
yeah, there are some libraries used in Graphviz, at least for the published versions, which are under licenses that are not compatible. And we need to have all the source code available for the IP review. So we needed to change some regular expression stuff in the source code, and we stripped it down to have only the libraries that we really need to do the layouting and to do a basic image export. And because that is what we really want to provide at first, and maybe we can extend on that later if we get the first version out sometime. That would be a huge improvement already. So, okay. Thank you very much.
Thank you very much.